right, long time no see. Now, some of y'all, if you're watching future generations from now, and you're watching this and you're wondering, hey, Mr. Metcalf's not wearing a shirt or tie. He doesn't even have a collar on. He's not wearing Charlestown high school stuff. What's going on? Well, today is an e-learning day, and the crazy year 2020. So there's no students. This is all e-learning this week. And to add a little mystique to my outfit, I'm not gonna lie, I'm actually wearing shorts too. Yeah, but they go to the top of the knee, so let's not get crazy. They do. Don't wear those short shorts anymore. We did back in the 80s, man. That was the style in the 80s, but not anymore. All right. Now, I realize sometimes I just love teaching geometry so much, I just jump right in and start teaching. And some of y'all might be saying, man, Mr. Becker, where's this bus going today? I get confused. You just jump right in and teach. Well, by the end of today's lesson, you will be able to identify angle relationships that are formed by two lines cut by a transversal. Now, that might not mean anything to you right now, but it will here in a few screens. So that's what's going to go on. There's going to be more angle relationships. You're saying there's more than just vertical angles and adjacent and linear. Yes, there's more. All right. We're going to bust out 4 very important ones in today's lesson. All right, so let's jump in and get started. We're moving into chapter 3, section 1. By the way, real good job by most of you on that chapter 2 test. I know we all took it online this time. The results were pretty good. Some people got locked out, but that was expected. And but a lot better job. A lot of you all took it, knocked it out on that Friday. I appreciate it. All right, so here we go. Lines and angles. All right. Now, a couple of textbooks ago, on page 171. You don't have don't look it up in your online textbook because it's not there. They have an example of an Ames room. That's AMES room. It's a pretty cool little trick they play on college students. I'm going to have you Google it, and you'll see some examples of Ames rooms, I'm sure. It's an optical illusion thing. You look in, and there's a woman who's looks like she's really tall, and then there's a guy who looks like he's really short, and you'll find out it's an optical illusion. All right, so Google that, and you'll see what I'm talking about. So we're going to jump into parallel lines. Now, when you were in middle school or whenever your teacher taught you about parallel lines, they probably gave a very simplistic definition. They probably said something about lines that never touch, which that's okay for where you were in your life then mathematically. But parallel lines, it's a little more complicated than that. All right, so parallel lines, a long vocab word. We're going to use kind of what I call a tipsy 11. It's like an 11, but he's kind of leaning to the side. That's our symbol for parallel lines. So whenever you see a tipsy 11, I'm talking about parallel lines. So here's the high school definition of parallel lines. Coplanar, and this is why your middle school teacher didn't tell you this definition, because you don't know what the word coplanar means. You do now. Coplanar lines that do not intersect. All right, saying lines that don't intersect is not good enough, because I could do this. See, I got my 2 lines, and you're like, oh, they look parallel, but what if I did that? These 2 lines are never going to touch. But anybody out there think these are parallel? They are not. We're going to learn what these are called on the very next slide, I think. But so you need but the reason is they're not coplanar. This line and this line are in 2 different planes. Their planes intersect at some point, but they're in 2 different planes. So you got to throw in that word coplanar. Now they're in the same plane, right? And they don't intersect. So that's a much better definition of parallel. All right. So, and here we go. Not only do we have a new symbol and vocab word, but we have a new annotation. Ooh, that's a good word, annotation. We indicate lines are parallel by putting what we call arrowheads. All right, so you see that red arrowhead there and this red arrowhead there. That is me indicating that line JK and line LM are parallel. Boom, and there you see the tipsy 11. All right, so those 2 lines are parallel. You know it because it says it right here. You're thinking you know it because they look parallel, but you know for sure because of these arrowheads. All right, so there's parallel. All right, any questions on that? Coplanar, that's key. Because like I said, if I do something crazy like this, they're not going to ever touch, but they're not parallel either, right? Okay, one down, moving on. Screen 2. What I just did with the rulers, making them like weird like this, where they don't touch but not parallel, that is called skew. All right? You might have heard an old person say he's looking at you askew. All right? That means he's kind of giving you like a side eye. That's what they say on those housewife shows or something like that. Skew or askew is like off kilter. Ooh, that's a good word too. Kilter. People don't say it much anymore. Lines that do not intersect and are not coplanar. All right, they're not in the same plane. They're in two different planes. And the key thing is they're also not parallel. Now, you can have parallel planes. All right. So if I remember, plane is the best way to demonstrate, kind of help you understand what a plane is. It's just like a slice of paper that goes on forever. So yeah, planes could be parallel. I could set them on top of each other like this. Hopefully I can see that. So these are parallel planes. And the only other choice for planes is they're either parallel or they're going to hit each other at some point. Can you do that skew thing, Mr. Metcalf, with planes? Nope. Because remember, these slices of paper go forever. So if I try to turn one, like eventually they will hit. So they're either parallel or they're not. All right. There's no such thing as a skew plane. All right. And here's something just more for your information. I got line L sitting here on plane A. I got line M sitting here on plane B. Now, lines L and M are skew. You see, this one's kind of doing this, and this one's kind of doing this. They're on parallel planes, but the lines are skew. So, again, that's not going to be on the test or anything like that. Just, yeah, you can have skew lines on parallel planes. So, just a little piece of knowledge. I'm sorry, I'm probably blocking the view there. So there you go. And again, pause if you need to. We're moving on, man. Some vocab words. Ooh, okay. So another three-dimensional drawing. You're like, man, Mr. Metcalf, I can't draw that beautiful wedge of cheese. You're a trained geometric professional. It's not as hard as it looks. And this is what we call a wedge of cheese. To draw this, I'll give you a quick tutorial. So hopefully you get your paper and pencil ready. What I'm going to do is I'm going to draw this top slice of the cheese, the JKL. So I'm going to draw that triangle. Oops, not even on my pen today. J, K, and L. All right, now here's the key. Oops. The key is don't put K directly above L. That'll mess things up. So if I was trying to draw this, there's my J, my K, and my L, and like I said, do not put K directly above L. That'll mess things up. So there's that top of the wedge. Now, directly underneath it, I'm going to draw the same triangle again, but it'll represent PQR. And this edge and that edge need to be dotted because they're in the back and behind the wedge of cheese. So they're there, they exist, but you couldn't see them in real life. So now try to directly, like see how J and P are directly on top of each other. Do the same thing with your drawing. So here's my P right here. And I'm going to try to draw this same triangle directly underneath it, but two of the edges are dotted. And believe me, it's more fun when you make the sound. And then this one would be solid because it's out in front and you could see it. So there you go. And that would represent R and Q. Now, you match up the guys who correspond to each other. J matches up with P, L matches up with R, and then K to Q, that is in the back of the wedge of cheese, so you couldn't see it, so that's dotted. And there you have it, a nice three-dimensional wedge of cheese. That's not too bad. It's not too bad for doing it and looking at the camera at the same time. All right, so now that's my tutorial on how to draw a 3D wedge of cheese. We got some questions. All right, first question. list all segments that are parallel to JP. All right, so what are the segments parallel to JP? JP is this guy right here. All right, which segments would be parallel to him, meaning if you extended them, they still would never touch, and they would be in the same plane together. Not that skew thing. We'll talk about skew in a minute. So, hopefully you paused it and you picked out the ones you thought were parallel. But parallel to JP would be LR would be parallel. So I'm going to write that down. LR. And so he's parallel. You can see my motion with my pen here. And then those would be parallel. And then one other guy, KQ. He would also be. KQ would be parallel. All right. Any questions on that? Pretty easy one, right? Now, let's go to this new vocab word, skew, which you probably had never been introduced to until about last screen. List a segment that is skewed to KL. All right, so I'm going to use, I'm going to highlight KL, and let's highlight it in a pretty purple color. Here's KL. That's this guy right here. So we want to never touch him, but not be parallel. All right, so here's KL. He's the back top edge of the cheese. I don't know if you can see that very well. So we want somebody who's not going to ever touch him, but also not be parallel to him. The only one that's really parallel to KL would be his buddy down here, QR. They would be parallel. So we don't want to say QR. I hope nobody put that answer down. And don't say JK, bam, because he's going to crash into him. Don't say JL. JL is going to crash into him. So somebody who's not going to ever hit him, but is not QR. So there's a handful of examples on this one. PR would work. Now some of y'all are saying, but Mr. Metcalf, if you extend that and you extend this, they would hit. That's because this is on a three-dimensional board. I mean a two-dimensional board, and I'm drawing a three-dimensional figure, right? But in real life, the top back edge of the wedge of cheese would not hit the bottom front edge. It would be down here doing this. I know it's hard to see. Man, the people who are in person, which is actually nobody for this lesson now that I think about it, they would see a beautiful representation of this, how he's going down here and he's going along up here. So they're never going to touch each other. And same thing for the back bottom edge as well. PQ also. So for that one, PR, Pleasant Ridge, and PQ, always mind your P's and Q's. Yeah, another old people saying. That one does have a meaning. I don't know if anybody looked it up. Last time I said mind your P's and Q's. That does mean something. It has to do with Irish pubs, which you don't need to worry about that right now. But yeah. So is anybody else skew? Oh, one other guy would be skew, would be JP, because JP's going straight up and down up here. He's the front, like pointy edge of the wedge of cheese. He's doing that. I don't know if you can see that. And then of course KL is the top back doing this. And man, you just really can't see that very well on a Chromebook. But yeah, they would also be skew. So there's definitely three skew ones that are drawn. I mean, you could also go JQ. There's no thing connecting JQ, but that would also be skew to KL. But they were not drawn. All right, so last question. This will be an easy one. The parallel and thing, I think that's pretty easy for most people to see. They just don't ever touch, and they're doing that thing with, yeah, okay. List a plane parallel to plane PQR. So PQR, I'm going to use my backup drawing. Plane PQR is the bottom. PQR is the bottom of the wedge of cheese. So, yeah, it would be all this. And obviously, who's parallel to the bottom of the wedge of cheese? The top of the wedge of cheese, right? So J, K, L, any combination of those three letters, you could name that plane. So plane JKL. That's the top of the wedge of cheese, and then the bottom of the wedge of cheese. They would be parallel. Any questions on that? Awesome. I think the next screen is a skip. It's the exact same concept, but now we've got a cube, or what we'll learn later on is called a prism, not a prison. Famous Metcalf story. Long time ago, pre-Greater Clark, I'm talking North Carolina, kid came in and said, "Hey, Mr. Metcalf, what we learned about today?" And I said, "We're learning about prisms." And he said, "I got an uncle who's in prism." And no, it's prism with an M on the end, not an N. Totally different thing. All right, so this is optional. Same questions they're going to give you who's skew, and if you want to draw that, I'll step out of the way. If you want to practice at home, you can copy it and quiz yourself with it if you like, but it's optional, so we're going to move on. All right. Transversal. Okay, there's that prefix trans again. Trans, like I've always told you, whenever there's a prefix trans, something is crossing to over something or to something else. The transitive property, if A equals B and B equals C, then A can cross over B to equal C. That's the transitive property. Transversal, what's he crossing? Okay, a transversal is a line that intersects two or more coplanar lines at two different points. So you've got two lines, coplanar, they gotta be in the same plane, and then the transversal is gonna be a guy who cuts across both of them. So if I had a third yardstick, you'd see that better. I guess these are meter sticks, aren't they? Yeah, these are meter sticks. Well, actually no, one's a yardstick, one's a meter stick. Is that right? No, they're both yardsticks, but then they got centimeters on the back, or one of them does. Huh. I'm sorry, I'll edit all that out. You know. So yeah, so you got two lines, and then if I had a third yardstick, I would draw one cutting across both of them. All right, and that third one would be the transversal. All right. So in this beautiful diagram here, I hope you can see that the colors are kind of faded out on my screen, but you've got T is the transversal. T doesn't have to be the name of the transversal, but there he is, and he's cutting across this line and this line. So he is a transversal as long as he's cutting across two or more at different points, and he is. And what happens when he does that? It creates 8 angles. 1, 2, 3, 4 up here. 5, 6, 7, 8 down here. It creates 8 angles. And the rest of today's lesson and next lesson, we're going to be talking about the relationships that are created. Everybody up here has a relationship. There's 4 different relationships with somebody down there in the bottom. So that's where we're going to spend the bulk of our time. But before we do that, another easy concept is just the whole idea of being inside or interior and outside or exterior. And what they're talking about inside and outside is the two lines that are getting cut across. All right, so here's the two lines, and then T's cutting across them. It's creating like an inside area, which I have shaded in this pretty green color. We call that the interior. So 3, 4, 5, and 6, those 4 angles are on the interior angles. And then 1 and 2, they're outside up here in the lavender area. And 7 and 8 are outside in the exterior area down here. So you've got an inside, which is in between the two lines, and then an outside, which is outside the two lines. All right. And I've basically summed up what this says. Interior, and those angles are 3, 4, 5, and 6. The exterior angles are outside of the two lines. That's 1, 2, 7, and 8. All right, so take a few seconds. Most people will get the whole concept of inside and outside. All right, any questions on that? Okay, moving on. I'll give you some time to copy this screen down. This is a detailed explanation of the 4 new angle relationships. Same side interior, alternate exterior, and corresponding. All right. So I'm going to step aside, you hit pause, copy that down, and then we'll process that over there on that screen. You don't have to redraw this. It's the same picture as on the last screen, except for I don't have it the shaded in area. I think the angles are all the same and everything. So if you want to use that last picture you already drew, you don't have to redraw it. So I'll step to the side, and first, yeah, it's probably my newest shirt in my eclectic T-shirt collection here. It's only the second time I've worn this one today. It's famous Chinese restaurant, former. It's not there. It's not called Liho Folks anymore. I think it's still in existence, but it's a different name now. Famous restaurant in Chinese restaurant in England. Ask your parents or probably your grandparents now about a song called Werewolves of London by Warren Zevon, and that'll bring you up to speed. All right, so you all take a few seconds to copy that down, and we're back. Okay, so you've copied this down. Here's the 4, and this is, like I said, this is the bulk of the lesson right here, and the next lesson, which will I'll save it for next lesson. All right, so the cool thing about these is their name kind of helps you decide who is who. So same side interior. Now, one key is that each person up here has one of these relationships with somebody down here, all right? So if I say same side, and I'm talking about angle 4, and you say, well, angle 1 is on the same side of the transverse. No, he's always going to have a relationship with somebody in the other group, all right? So these guys are going to have one of these relationships with somebody in the other group of 4, not here. Now, if we're talking about some old relationships we learned about, like linear pairs, 1 and 2, they would be a linear pair because they're next door neighbors on a line. 1 and 3 would be vertical because they're across from each other in that perfect X. But the 4 new ones we're going to learn today, each one up here has one of the relationships with one of them down here. All right. So same side interior. Nerds call it consecutive interior. Obviously, we're going to use same side interior. They're interior angles. So right off the bat, you've got it narrowed down to 4. All right, because there's only 4 interior angles: 4, 3, 5, and 6. All right. They're interior angles that lie on the same side of the transversal. So if I'm talking about 4, his same side interior buddy would be 5, because it's got to be somebody down here. He's got to be somebody on the interior. So right away, it's got to be 5 or 6. And then the fact that it's called his same side buddy means he's on the same side of the transversal. So here's the transversal, and the only one who meets all those requirements with 4 is 5. So angles 4 and 5 are same side interior buddies. And then on the other side of the transversal, 3 and 6 would be same side interior buddies. Does that make sense? Probably, I hope. Now, alternate. Alternate's a fancy word. It means on the opposite side, okay? So alternate interior angles. So if I go back to number 4 again, some of y'all say, well, 3 is on the alternate or opposite side of the transversal, but you got to remember, it's got to be somebody in this group down here, all right? 4 is not going to have one of these 4 relationships with somebody in his same group. So his alternate interior buddy, again, it's got to be 5 or 6 because those are the only ones on the interior, but it's going to be 6 because 6 is on the alternate or opposite side of the transversal, right? There's T, so it's 4 and 6. That would be the alternate interior buddies. And who can tell me the other pair? There's one other pair of alternate interior buddies. Okay, I hope you said 3 and 5, right? 3 and 5 are the other pair. So angle 3 and angle 5. All right, alternate exterior. Okay, So we're switching gears. We're not talking about guys on the inside now. Alternate exterior. The fact that it says exterior wipes out angles 4, 3, 5, and 6. So now we're talking about 1, 2, 8, and 7. So angle 1, he's got an alternate exterior buddy. And of course it can't be 2 because 2's in the same group. So who is in the bottom group down here that's on the exterior and on the alternate side of the transversal? Well, yeah, everybody's in the studio audience is raising their hand saying 7. Yeah. So his one's alternate exterior buddy would be 7. It's got to be 7 or 8 because of the word exterior. And it's got to be 7 because he's the only one who's on the alternate side of the transversal from 1. So it's 1 and 7. And what would the other pair be? You're right. It would be 2 and 8. So angles 2, and I'm just going to put a comma, angle 8. All right? 8 and 2, both on the exterior and on alternate sides of the transversal. Okay. Now the last one, corresponding. This is the only one where, in these new 4 that we're learning, the only one where it doesn't have the word either exterior or interior, and that's because it can't. Corresponding angles will always have one guy who is on the interior and one guy who's on the exterior. That's just how it works. So they don't have corresponding interior and corresponding exterior. That just doesn't work with corresponding. Corresponding is a fancy word that means matches up with. All right? I don't want to go into connecting it to a vocab word, correspondence. I could, but it just think of it as matches up with. So what does that mean, Mr. Metcalf? Blah, 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 textbook definition right here. Matches up is a much better way to think of it. So let's take a look at angle 1. So he's in this top group. He matches up with one of the angles down here in the bottom group. And matches up, I mean he's like in the same position, but he's in the different group. So if you look at angle 1 in this group of 4, angle 1 is in the top left corner, right? You all would agree with me? Angle 1's in this group of 4, he's in the top left corner. Well, come down to the bottom group. Who's in the top left corner in this bottom group? Well, 5 is, right? That means they match up. They correspond with each other. So angle 1, his corresponding buddy is angle 5, and that's what I got right here. And then they move on to angle 4. Okay, so angle 4 in this group, he is in the bottom left corner, right? He's in the bottom. 4 and 3 are in the bottom, and he's in the bottom left. So who is in the bottom left down here? Well, that would be 8. So 4 and 8. Now, you take a couple of seconds and you jot down who you think the other 2 corresponding pairs would be. You mean there's 4, Mr. Metcalf? With corresponding, there will be 4 pairs, whereas in the other ones, there's only 2 pairs. All right? So take a few seconds, and we're back. All right. So let's see. We did 1 and 4, so let's move on to 2. All right, so I'm going to underline 2. In the top group, angle 2 is in the top right-hand corner. So who is in the top right-hand corner of this group? Well, 6 is. So angle 2 and angle, that's the word and, angle 6. All right? And the only one we haven't done yet is we've got 1, 2, and 4, so 3. We'll double underline 3. 3 is in the bottom right corner of the top group. Who's in the bottom right corner of the bottom group? Well, 7. So angle 3 matches up with angle 7. All right. Any questions on that? Any questions? So, like I said, try to get those firmly established in your brain. Remember, the names kind of help you. It tells you 3 of them. It tells you interior or exterior, so that helps you quite a bit there. And then when it says same side or alternate, they're talking about in relationship to that transversal, that thing that is cutting across everybody. All right. Okay, moving on. I think we're gonna have a beautiful picture Oh, I've got 8 problems here. We're going to process 1, 2, 3, and 4 together. See the little line where I'm going to cut it off there? We're going to process those together, and then you can quiz each other on 5, 6, 7, and 8. I'll step out of the way so you can copy them all down. But this is a new drawing, so you do need to make this drawing. This one, the angles are numbered differently on this one. So now instead of having a top group and a bottom group, we kind of have a left group and a right group. But we still have 2 lines cut by a transversal. So this is your transversal line. Transversal. Okay, that's the transversal line. All right, so first off, we're classifying the angle pairs. So which one of those 4 relationships that we just learned are these? I don't think I went back. Maybe on some of the other questions I might have gone back and got like vertical angles and linear pairs, something like that. But I don't think I did on the first 4 that we're going to do. So let's take a look at the first one. Says angle 1 and angle 5. Angle 1 and angle 5 are both on the exterior, right? The interior is 2, 7, 3, and 6. Those guys are on the inside. 1, 8, 4, and 5 are on the outside in this drawing. So 1 is on the outside, 5 is on the outside, and if you want to put out and out, that kind of gives away. It's not corresponding, because remember, corresponding you have to have 1 on the inside, 1 on the outside. That's the only one that's like that. And so we're talking about 1 and 5, so they're both exterior. So are they alternate exterior? And I do believe they are, because here's the transversal. 1 is on top of the transversal, 5 is underneath it, so they're on alternate sides. So they would be alternate, or as I'm going to put, alt-ext angles. Alternate exterior angles. Does that make sense? I hope it does. 6 and 7. Okay. 6 and 7, or here they are. They're both on the inside. So they're interior angles. So that means they're either going to be same side interior or alternate interior. Those are your only 2 choices when they're both on the inside. So 6 and 7, they're both underneath the transversal, so they're both on the same side of the transversal. So they are same side interior. Easy stuff, right? Easy stuff. Okay, 2 and 4. Let's see, 2 and 4. Okay, I'm gonna start marking this up a little bit. Here's angle 2. Here's angle 4. Now I noticed there. Ooh, here's the giveaway on 2 and 4. Check this out. You already know it before I even explain it, right? 2 is on the inside. 4 is on the outside. And the only one that does that is corresponding. So now let's just see if they match up with each other. Okay, if you look at this group of angles, 2 is in the top right corner. So you look at this group of angles, and 4 is in the top right corner. They match up, or they correspond with each other, and they're corresponding angles. I'm sorry about my cursive, but there you go. 2 and 6. Okay, so we're talking about 2 again, so I'm going to circle him this time. Angle 2 and then angle 6. What relationship do they have? Again, they're both on the inside. They're both interior angles, inside the lines, right? But they are not on the same side of the transversal. 2's above it, 6 is underneath it, so they're on the alternate sides of the transversal, meaning they are alternate alt-interior angles. All right, and I think we hit all 4. Yeah, we hit all 4 of the different types. So I'll let you all, if you want, at the library tonight or tomorrow night. Not tomorrow night. Tomorrow night we got a game, so don't go to the library on Friday night, unless you got a big test Saturday morning and you're in college or something, or big report or something, dude. But yeah, Friday night, and go to the football game. I know it's limited capacity because of this COVID stuff. Just try to get you a ticket or something. It's the first game on our new field. Oh my goodness, I was driving by it today. They're almost done, man. It's looking pretty good, but they're supposed to have a game there tomorrow night, and I have game duty, so that's how I know that. So I'm gonna be there Oh, and history, man. I'm gonna have to get myself a ticket stub so I can frame it one day. The first game played on the new turf field at Charlestown High School. Man, that's some exciting stuff, man. Okay, great day to be a pirate, right? Well, tomorrow, yeah. Okay, so that's that. And like I said, you got these four. Again, if you want to quiz each other at the library tonight, don't go tomorrow night during a football game. It's silly. All right, so, oops, didn't click. There we go. This one is kind of the same deal. They want to know the relationship of, you're going to notice that the drawing is a little more complex, but then they also want to know the transversal that connects them. All right, so I've got more lines than just the two getting crossed by the one. You're going to see my picture here, and as soon as I step aside, there's more going on in this one. So not only do they want the angle relationship now, they want the transversal that connects the two groups of angles. All right, so I've added a little bit of flavor to it. We're going to do 3 of these at the most, because you're going to see how easy it is in just a minute. I got a bunch here if you want to, again, practice makes permanent, as we say. All right, so here's the drawing. You're saying, Mr. Metcalf, that's too complicated, I can't do it. Yeah, you can. What you want to do is you want to draw a tall, skinny X. So I'm going to do that right here. Draw a tall, skinny X. So that's this and this. And then up in the top area of the X, you want to do a short and kind of fat X meeting in this area right here. So I'm going to go kind of like whoop, and there you go. It's kind of like some kind of weird robot looking guy I've had students say in the past. And then you just need to label the lines, like this is H, that's a cursive H, and I'll just write it in print, and that's a cursive J, and then down here that's a K, and lastly an L. All right. So, and then the angle numbers are 7, 8, 9, and 6, and then up here I only have 2 of them named, 1 and 2, and then over here I got a 4, and up top is a 3, and then over here by himself is 5, man. 5's all alone. Okay, so there's the drawing that we're going to use, and again, I'll process the first one, and then I'll pause and let you all do the next 2. So angle 1 and angle 3. All right, so here's angle 1, here's angle 3. All right, so here's right away, they're connected by line H. So that's the transversal. So line H, and you're supposed to make that in cursive, and then put a line with arrowheads over it to show it's a line. So my transversal for 1 and 3 is H. Does everybody see that? No other line on this drawing that has several. How many? 2 or 4 lines, it looks like. No other line connects angles 1 and 3 except H. So that's definitely the transversal. So now, what's the relationship between 1 and 3? Well, here's the inside. Only angle that's marked inside is 2. So 1 and 3 are definitely on the exterior. Are y'all getting that exterior, interior thing? 2 is the one on the inside. 1, 3, and 4 are exterior, but we're only talking about 1 and 3. So they're exterior, and if this is the transversal, 3 is on top of it, 1 is underneath it, so they're on opposite or alternate sides of the transversal. So they are alternate exterior angles. All right, 1 and 3 exterior, and then alternate sides of the transversal. Pretty easy stuff, right? 5 and 6. So now we're going to pretend like you've paused it and you're doing 5 and 6. Okay, what did you get for 5 and 6? I hope you got, well, let me figure out what it is first. Okay, first thing you want to do is find out what is the only line that connects angle 5 and angle 6, the only one they share. Well, here's 5, here's 6. The line that they share is this one right here, correct? 5 and 6, and that is line K. So the transversal for 5 and 6 is K, hope that's okay. And then if you look at line K, 5 and 6, they're both on the inside of those lines, right? So we're talking about interior. And they are on the same side of the transversal. Here's the transversal. They're both to the right of the transversal on the same side. So again, that gives it away. They would be same side interior angles. All right, y'all getting this? I hope you are. If you're not, man, Mr. Crabtree will probably have a Google Meet at some point. This homework, oh, by the way, this homework, we'll say, you know, the other class isn't going to see this till tomorrow, which is Friday. So we're going to have this homework be due on Tuesday. Maybe I can talk Mr. Crabtree into having a Google Meet like Monday or Tuesday afternoon. And then it'll be due like at 11:59 Tuesday night. All right, so we'll do one more because I think you're getting the hang of it. We'll look at angle 2 and angle 6. All right, angle 2, I'll circle him. And angle 6, I'll circle him. What is the line that connects them? The transversal line. The only line that connects angle 2 and angle 6 is this line right here, which is line L. So that would be my transversal line. And then what is the relationship between 2 and 6? Okay, well, oh, I know what it is already. I hope you do too. When I block them off for interior and exterior, I notice that 2 is on the inside, but 6 is on the outside, all right? And there's only one relationship, one of the new 4, that does that. That's corresponding, all right? So I'm going to, well, you know what? Before I write down corresponding, I'm going to say, do they match up with each other? Okay, now these are kind of cockeyed angles. So if you look at this group of 4, we'll have a top, bottom, left, right. If you look at this group of 4, 2 is the right over here on the right hand corner, and then you look at this group of 4, angle 6 is over here on the right. So they do match up. So the matching up we call corresponding, or I just call core, C-O-R-R period, corresponding. Man, I hope you all got that. You got some sample problems over here, like 4 more you can do and quiz each other and say, hey, which one did you get for number 4, man? Which was your transversal and that kind of stuff. Use that texting and social media for like good stuff, like helping you stuff, instead of just saying whose picture you don't like and stuff like that. So yeah, so there's those. And that might be the end of the lesson. I think it is. I think this is a little teaser for lesson. Yep. I'm gonna go back on that. So the next slide is like chapter 3, lesson 2. So we'll get to that next time. I hope you all got that. Again, remember 4 new angle relationships. When you have 2 lines cut by a transversal, it creates 8 angles. 4 in one group, 4 in the other. And then there's these 4 new relationships. And there's still the old relationships. There's still vertical and linear pair and adjacent. Those are still in there, but we're talking about these 4 new ones. All right, I'll see you next time.